We are Pet Tech. My name is Alan Szczepek.
I'm Noah Kiger.
I'm Shamar Goodridge.
Jesse Rook.
Joshua Tolbert.
And we designed the automatic cat door, or as we will be referring to it from now on for shortening purposes, the ACD. So let's start off with the problem. Our client was Dr. Mark McKenney, and he told us the story of how he adopted a feral cat, and as much as he loved it, it annoyed him at how much he had to let it out. He did not like having to open and close the door continuously because it wanted to be an outdoor cat. So he said, hey, can somebody please help me and make this so where I don't have to do it and something can do it for me. So we came up with the automatic cat door.
So sort of going into the main process of the door, we have the cat, which is implanted with the RFID chip that was implanted at the vet. And that goes through our detector circuit, which is the RFID loop. And from there, that goes to the processing unit via the UART, and we can use the chip that it read to unlock the door, open it, close the door, all sorts of operations.
And here we have a solution of the video. Unfortunately, it decided to not work for the showcasing earlier due to technical difficulties, but we do have a video with our main star, Shamar.
Hi, we're Pet Tech, and we'll be demonstrating the automatic cat door. To begin, we're going to wave an unauthorized chip, and you're going to hear the buzzer go off because we haven't seen it yet.
It's supposed to go off for 10 seconds.
The sound of the alarm doesn't sparkle if you can mute it.
Exactly. Make it more colorful.
No alarm because we muted it. But for the rest of this test, we're going to unmute it because I like the sound. Next thing we're going to do is we're going to sync this chip. So, you're going to press the sync button, and the door is going to open. We're going to run the chip through. And now this chip is synced to the device.
Ghost cat.
So real quick, what happened there was it has to hit a limit switch on the bottom of the door casing, and that is what tells the system that, hey, the door is closed. And it didn't have a good enough read, so it decided to go, let's try that again. And then it actually worked.
You tell the sync to the device because we're going to check it again. It's time the door opens. I'm going to test the door stuck, so if your pet is still in there or there's a stick or something in there and the door wants to unlock, a loud alarm will go off and alert you that something's stuck in the door. Can't mute this alarm. You got to fix that. You can fix that by pressing the reset button. And then to show that these chips are stored non-volatile, we're going to remove power to the device. Put power back on. And what we're hoping to see is that the chip makes the door open again. This has been the demonstration of the automatic cat.
There you go. So as everybody can see, it does work. Anyway, so my module was power. We went through a bunch of different iterations with how to actually provide power to this thing. At first we started off with just a 9-volt battery system. We made the determination that that wouldn't be enough to drive our solenoids and motors and all that. So then our second iteration, we were going to use you know, a knockoff Greenworks type battery that you would normally use for your lawnmower. The problem with that then is that we had to step down a lot of different voltages from 40 volts DC to all the way down to 5 volts. So we're getting a lot of heat losses and a lot of issues due to that. So we finally decided, thanks to Mr. Knapp, to kind of give us this idea. Since we only need to have power to the module when the main door is actually closed, we could use contact chargers like you have with cell phones to power the entire thing. So as you can see here, this plugs in to wall power, contrary to other groups' beliefs. We are using wall power too. And then from there, it basically steps it down and then converts it to DC, but then reconverts it to AC in that oscillator, which turned out to be a much greater challenge than we anticipated when we got to the integration phase, because the oscillator, of course, operates at the exact same frequency as our RFID loop. So thanks to Dr. Mazzaro, we were able to borrow his spectrum analyzer and ended up getting this variable voltage supply to supply it, because we realized that we could underclock the oscillator if we operated at a low enough voltage. And we could have the spectrum analyzer and literally watch the peaks separate enough to the RFID loop working. And that's power.
Alright, so I work with the door, and that just generally goes through the motors, solenoid, the door's operation, and some safety features. The door went through a couple different iterations. Our first idea was to do a 2-rail system with a rail on either side of the door, driving up and down. But thanks to suggestions from Mr. Knapp again, we decided to go with a single rail system, lowering our power consumption, just generally making things more simpler, simplifying things. Another pretty big change was we went from a DC motor, we went to a stepper motor, back to a DC motor. We went to the stepper motor because we wanted some fine-tuning control. We decided that was a lot more trouble than it was worth. So we went back to the stepper motor with limit switches that the door has to hit. And then the solenoid lock, we went through 2 or 3 different iterations just to try and find a solenoid that works with the voltage that we were supplying to it from the H-bridge. It just pops it, locks it, locks in the top position. Everyone flinched when it turned on, I saw. It was just locking, it's fine, it wasn't doing anything wrong. And then the safety features going through it was part of my job. And the safety features are cat check and door stuck. Door stuck was pretty clearly demonstrated during our video. Just that when the door starts to close, if it detects any kind of resistance, the door will then set off the alarm, open back up, and say, "Hey, user, something's stuck. Your cat's sitting here, and for some reason I don't see it." So the idea behind that is one of our main objectives is to keep pests out. And if something's stuck and the door won't close, then we can't complete our objective. So the alarm tells you that, "Hey, come check it out, or else something will get in your house." The cat check wasn't super well demonstrated, or wasn't pointed out, but basically how cat check works is we have 2 IR sensors that will be explained later, and the door will not close unless those IR sensors don't see anything.
As far as the interface goes, we used an Raspberry Pi 2040 Pico. Right here is a picture of our IR sensors. Now we have 2 of them, one located on the inside and the outside of the door. Both of them are very, very, very sensitive. Even the slightest movement will trigger one of them and the door will open. As far as our button layout, Shamar showed in the video that we have the sync mode, which is basically you just press the sync button, scan the chip, and then the chip is forever synced to the door. The mute button, because the alarm is very, very loud and very, very annoying, so just press that, and then other than the door stuck for the alarm, it'll mute. We also have an LED located on the back of the door, just in case if you do mute it, you'll still see the alarm, the LED go off, just in case there is an alarm. And then we have the reset button for just in case the door does get stuck. If we were to fix this in the future, we definitely get different IR sensors when we could adjust the sensitivity of them, because yeah, the IR sensors were really, really sensitive. I mean, if you had it over here and you moved over there, it was going to sense, so yeah.
Ghost cat is real.
Ghost cat. Ghost cat.
So going into some more of the mechanical side of it, so this is the actual loop. This is what your cat will step through to get their chip read. That is a 20 centimeter loop, and that is big enough for most size cats, even the bigger ones, and pretty small dogs. So call it a cat door, but it'll fit your chihuahuas. And here's what it looks like in real life.
And this is just the schematic of the loop and housing of everything that we saw in the video. You see the actual, we saw the actual loop that we just looked at right there. Our doors housed right there, our IR sensors right there and there. A solenoid is housed right there that locks this door in place. And then our motor controls the gear and rack and pinion is the technical term. Our gear and rack that work right there. And this is, again, the actual door itself. Again, motor, solenoid, door, IR. There's another IR back there you can't see.
Looks like a gila.
Just gonna skip the Gantt chart. We
Cat
completed
cutter.
everything on time. All right, for the budgeting, due to testing purposes, we had a little bit of a over expenditure on just spare parts. Today was a good example of showing we like to burn out Picos. So the total expenditure for just the project and not the design was how much?
Just
It was the 237.
This is the new stuff.
Yes. Okay. So it was 237 total for the actual project, but the design was about $60 more because we ended up getting that battery and not needing it. This goes further into that.
Just looking at a quick budget analysis, we planned on selling at $350 because the competitors on the market sell at $610 with a $6 subscription fee. That sucks. And looking at our actual final cost being about $237, we did quick maths, will give us a 47% profit margin.
And this is the only competitor that we could find, and even their product was also in development. If we were to continue this task, as we said, we would try to get IR sensors that were not as sensitive. We would definitely try and pretty it up a little bit because the guide rails were a last minute thought, but they are a lifesaver. And hopefully, when it decides to not burn itself out, we can show it to our clients and produce the product for them. Any questions? We did not get the memo of putting precious memories at the end like everyone else. So, cute cat.
I have a question for Mark. Would you mind bringing your cat in and putting it through the trial maybe sometime for the video?
So, unfortunately, that cat has since passed away.
Sir, is it too early to say that Ghost Cat is real?
Ghost cat.
Absolutely.
Ghost cat, yeah.
As long as he wasn't killed by the
No.
But yes, I would feel completely comfortable letting my cat go through the door.
Yes, ma'am.
We have the ashes still, I suspect.
So you still have the RFID chip still in there?
As I said, the chip is probably
Probably,
still in the
man.
pile of ashes.
Yes.
What is the average delay for the door to open upon sensing the chip?
Average delay?
Yeah, because it looked as though there was a little bit of a delay in the door actually opening once it sensed it. My concern being cats like to brush up on things, and so if it brushes up against the door and then keeps going, and then it opens, what do you do?
So if the cat wants to get in or outside and the door opens, brushes up, we have a time delay of 2 seconds. And it will open and the cat will move because cats are scared.
If the cat cleared both IR sensors, it would then close too. So if the cat
IR
just brushed up and
sensors.
then decided to go back inside and just left, then it would reclose.
Okay.
As mentioned, it was not demonstrated in the video, but the two IR sensors need to not read anything for the door to close. Otherwise, it will stay open so that when your cat, which likes to just lounge wherever it wants, it will not close on the cat. And even if it does, due to the door stuck feature, it will stop it from doing that.
Did you include that in the routine for teaching the sensor? Is it teaching the RFID?
What do you mean by teaching the RFID?
When you paired it in the video, you put the sensor in, the door immediately shut.
That also has door stuck and the cat check implemented.
Was it implemented in the video?
Yes.
It's part of the full check. It's on their. It checks for that constantly during the loop, so that if any of those conditions occur, that would guillotine your cat. It doesn't guillotine it.
Well,
If you wanted to, you can talk to me offline. I can
Slice some out.
take out the R sensors and then.
It doesn't have a chip. It's
This
not gonna
product
have-
can be rebranded into other things depending on the customer base.
we're planning a spin-off next year.
Very quickly. Say, well, it's almost all of you
I was project manager and also part of the interface module, and very quickly, the IR sensors were way too sensitive. We ended up having to jerry-rig it a little bit, but we would definitely try to find less sensitive ones in the future.
Yeah, I guess other than just those frequencies matching perfectly, probably getting the motor to drive the gear without slipping, because like the 3D print and the shaft was, the flat was so rounded basically that what I ended up doing was drilling a hole into it, screwing a screw into it, and then melting a counter hole into the plastic and then gluing that in, and that worked pretty well, but yeah.
The RFID chips, we need a resonance frequency to make those work. We didn't measure, there's no way to like affix that to what power we're using accurately, so it was a lot of trial and error. I remember sitting here with like a bunch of inductors trying to figure out where the sweet spot was so we can get good reads.
Big thing with the motor, solenoid, and power altogether is the motor and solenoid draw the most power out of this entire system, and finding the fine line where the voltage is low enough that the system doesn't interfere with our RFID detection, and still high enough to power both the solenoid and the motor was definitely a tricky spot.
As far as interfacing and coding, the hardest part was we had multiple subroutines and trying to. We had like different subroutines for each part of our, I guess each component. So it was hard to trying to figure out how to properly code and integrate all of our components together was the hardest part.